So next we'll be covering files and database systems. So this is one of the backbone and most interesting topics. So if you have to deal with the storage and data management for maybe for a long term or a short term, so this would serve in most of the application as a backbone. So we need to understand how to store and manipulate of different data so that it could be stored in a file or a database. So files, we are talking about the flat files, so we don't have to worry about any structured data, what kind of data it should be stored and how it should be stored. Everything would be dumped either in a hexa or a binary, whatever data we provide. So we'd be dumping everything in a binary data and reading it in a binary data and convert into whatever string or any kind of encoding, using any coding scheme. So you convert whatever we need to display to the user. So let's take an example how to start with the so this is a conventional way of writing files. Opening a file, just use an open of the Python, open method of Python, and assign it to any variable. So this will be an object. So this is a file object. So what we need to pass it to the open is the file name and the mode of writing. So the mode of file. So the mode would be it could be either read, write. So there are a lot of modes. So that you can check it out for the Python. So ideally we'll be using the either write byte or read byte, and there will be append, write append. If you want to do so, that would be represented by E, and if you want to do both read and write, you do use read write or just write. That would also work. So right now we'll be using dumping or whatever data using a binary, right? So we'll be using WB. So let's see, let's clear all the cells once. Okay, so now let's run the first one. So what it says is after that we are using the same object to get some of the attributes of it, like name. So we'd get the name written, and is the file closed, it's false, and the mode that we have already specified, and the soft space. So it's a flag for soft space, you can just search about it. So so the next it would be so once we have the file ready and the object ready, so we can use the file object to write it to the write whatever content we want to the file. So let's see, I think since I already run, so I already have a foo.txt here, so I'm gonna just delete that. Okay, so now it's deleted. So now let me open that again. Okay, so now let me write into the file. So once I have written into the file using the write operation, so you need to close, so you can look into the data of it. So you would not see anything until everything has been written. So written and closed. So let's close that file as well. So once you close that, you will be able to look into that. The content of whatever you have specified is actually in the file. So you can do the same thing the kernel also, with the terminal as well. So you can just go there to the intro, and you can check out whether that has a content. So you can see here the content which we had written. So the same content would be there in the Python notebook drive as well. Okay, so once you have closed it, so you can use an open again just with the read operator, read plus, just to read the file. It would again create an object, and you can specify how much your byte you want to read. So if you want to read the entire file, you don't have to specify anything. It will read the entire file, whatever the buffer, whatever, how much over the maximum read it can do, it will be read in chunks. So you can also specify a loop where you can read chunks of data. So right now we are going to read only the first 10 bytes of it. So when we run this, so once you have the str, you can just, once it's there, you can just print it out. So that's where done. So the first line is I have open. So the first 10 bytes, so since the string takes one character, takes 1 byte, so we'll be seeing 10 characters of it. So that's from 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So 10 characters will be seen. So after that, we'll look into some of the file positioning in the files. So file positioning is basically when you're reading, so our cursor of the cursor, it moves from one end to other. So once you have read the say first 10 bytes, your cursor will be in the 10th byte. So that's the reason you sometimes you want to go from one end to the other. So we need the file positioning systems or file positioning methods. So some of the methods which could be performed on this object are, so we'll do the same thing. We'll open it with the read operation, read file mode, and we'll read the first 15 byte. So what it should happen is the for our a position of the person should be in the 15th byte. So that's what when we run, we'll be able to say. So the tell operation says where exactly is my position, so it's in the 15th byte. So after that, so I'm doing one more operation to seek and go to the 0th byte. So once he had gone to the 0th byte, again I'm trying to read it, so I'll be able to read again from the beginning. So just let's alter this to 5th byte and let's see what happens. So now what happens is it has skipped the second string. As you can see here, it has skipped the first 5 bytes since we have given the seek. Then it's trying to read it from the after the first 5 bytes. So this is the rest of the strings as you can see. So after that we'll do a close. So there's also one more way of reading and writing a file. So that's the syntax would be a little different. So let's create one more cell here, and I'm going to create, so I'll just copy this. It's kind of similar to this, but the thing is, so you write a with operation along with that. So with open, and you say as, and you say the file object, and you write it as a conditional or follow with the statement ending with the colon. So once you have done that, so what you can do is you can do the read operation and you can print it. We'll do the same thing. So it's just as same as that. But the important thing here to notice is, let's learn this. So we'll get the same string over here. But the important thing with this is you can do the same write operation also with this. So we often tend to forget the close operation. So once if you are done with operations, once it comes out of this print statement, I mean this loop, it automatically closes file. You don't have to worry about it. So the thing is, let's do some pass operation and try to run this. So this would give an error. This is because you're trying to perform a read operation outside the with clause. So that's why this object has already closed the IO operation on closed file. So that's why you should be able to always perform inside the with clause. Okay, so I think you got a gist of files, how it's going to work. So basically we have gone through the concept of files just to introduce some other just to make sure that we know some kind of storage mechanism, and so then we can dive into databases of Python, which we will be using extensively in most of the applications. And there are a lot of libraries for the applications, a lot of libraries written out of the database. So we will be able to understand how the read write operation works once we know the file operations. So that's the reason I have selected a very simple database which actually kind of stores database in a file format. So we'll talk a little bit about Sqlite. So Sqlite is actually it provides an SQL interface which is compliant with most of the DB APIs. That's 2.0 specification which most of the database drivers use in Python, which is PEP 249. So PEP is nothing but a Python enhancement protocol that was some standard. So any time you define some standard, it has to go through the PEP enhancement procedures. So so one more thing about the Sqlite 3, it's so simple that and so lightweight that you don't have to install any modules. It comes along with the default Python installation from the 2.5 onwards, so you don't have to worry about it. Still in the 3.6 version also we can see the Sqlite 3 compatibilities. So okay, so there are a lot of methods, APIs it provides, or we can call the module subroutines. So and that should be able to so we have covered only few of the modules which is like really necessary in like CRUD operations. But if you want to dive into the Sqlite, it provides a lot of operations just like any other Sqlite. So you can check it out in the Sqlite documentation site or any tutorial sites, but we have given gist of information such that we can dive into and do performance, build any application with the Sqlite. So the important thing to notice is that you have to consider is that it's so important that we will be using in any application, and that is the reason I'm stressing, so that the same Sqlite we will be using in the later application that we are going to design at the end, one web application that we are going to design at the end. So it's better we understand a little more about the Sqlite drivers. So so since it comes with the bundle with the Python, we don't have to install any packages, so we'll directly import this Sqlite 3 package and we'll try to run this. And the first statement would be to connect to any test data. So if you have a test data, any database file which is like locally resided, you can name it, otherwise it's going to create a new data test. So I already have a test DB here, which I'll just delete it, so that I'll create a new one and we'll be able to insert new data as well. So let's run this. So this connection has happened now. So now I'm going to execute a creation. So this is like a normal SQL insertion and SQL creation of table, where we are saying create table, and the table name is workshop, and the first ID of we made it as a primary key. So this is quite similar to any of the SQL relational databases. If you have checked out, if you know MySQL, if you know Oracle DB, or everything, Postgres, everything is similar to this. It will be somewhat similar to this, the standard of writing. So we say that all these columns, that name, age and city, so we have also specified the type for that. The first one is a primary key integer, name is a text, and age is an integer, and the city is a character of size 50. And all these three attributes or column are not null. So that means if you're not entering anything to it, it would throw out an error. Unlike NoSQL, SQL is strictly you need to define a lot of whenever you define rules, you have to strictly follow while inserting or doing any CRUD operations on that. So once we have defined our structure, described our structure, we'll run it. So we'll get a cursor object. So we don't have to do anything with the create cursor. So the other cursor will be using it to do some other operations. So okay, so once you have the table ready, we'll insert some of the data to it. So I have like 4. So basically this table is nothing but a workshop. So I created a workshop table such that whoever attended the workshop, I will insert their name details into the workshop table. So now I'm going to insert so even the primary key I'll be inserting, not that they will be computing. So I'll insert a primary key, that's an integer sequence number, and name and age, and so this is the way to insert into workshop. That's a table name, and you give the whatever existing described column, and we will so if you change this change the order, you have to also change the order here. So this is the same tuple order that the inserted value will be inserted into this particular tuple order. So when we run it, so this is now committed. So now let's go to the select. So once you have inserted, you can see and look into the database. So let's also confirm that the DB is created. Yeah, so the DB is created here, test DB. So now we have the select operation. And the select operation is again the same. So you do the execute operation on that, and you do select ID, name, city, and the workshop from workshop. So now we are going to use the cursor object of this. So the cursor object will be traversing through it. So the cursor object is basically an iterator here, written here. So you can perform operations such as a fetch one, or so this is actually unnecessary. So yeah, so we can also see the fetch one here, over here. So if we are sure that there is only, or you want only a single row from that, you can use a fetch one, or you can use a fetch all, and you can specify what you want out of that, like so let's run this and check it out. So okay, so once you have the cursor object, you iterate to the cursor object and get the so this basically will be a tuple. So you are now row, you have a row, so you can also check it out what's the type of the, just to confirm, row. It's not going to be a cursor or cursor object, it's going to be a plain tuple, sorry. As you can see, the output which we got, it's a tuple. Sorry. Okay, so here you go. So it's a tuple. So all of them are tuple. So we are going to print out using the indexes that we learned in the tuple. So we'll be getting the name, ID, name, and the city, and that we're going to print out over here. ID, name, and the city. Okay. So okay, that's all about this. And then let's go to the one more operation, update. So once we have a data in the database, so it's all often happens that we have to update the data in the database of particular row or particular column. So whatever you might want to change all the data, all the columns or some of the columns. So now there's one condition that so let's consider you want to update an ID1, the first insertion, where you have misspelled or the city you have given wrong. You want to change it to Mumbai. So let's update. So this is a query for that. Update workshop set city is equal to Mumbai, where, and the where condition is pretty important because you have to have a single row when you want to update a Mumbai, one particular city, or it would basically update multiple rows if it matches more than that. So now once after that, after executing, you have to commit. So commit you have to often do anywhere you make any insertion changes, or so for select you don't have to do a commit operation. So when we run this, so we'll be able to see after that we are again querying for the same ID 1, and we are able to see the city ID has changed to Mumbai now. Okay, so the last operation in the CRUD is, so we have covered the create, read, update, and the last operation, the CRUD, is delete. So the delete operation is performed similar to the update. So delete from workshop where ID equal to, but here you don't have to specify any column, so you basically delete the entire row. So if you run that, so the ID2 should be vanished. So now you can see ID1, ID3, and ID4 we have, but ID2 has vanished. So yeah, so we had all the 4 here, over here. Yeah, so all the operation works fine in Sqlite. This is how you work within databases, relational databases, so in a Python. So this is just the basic database driver. So there are much more advanced databases, just Postgres, MySQL, Cassandra, and there are GraphDBs, which are like quite famous in most of the social networking applications. And people nowadays use NoSQL, Mongo for any data they want to dump in. So as we, we don't worry about describing the data anymore. So we are basically interested in data, and data description or the data definition happens at higher level. We don't worry about in the database level, as these are pretty costly in the database level to handle. Yeah, so that's all about files and database. So